Okay, for Eureka Math, let's kind of wrap it up for basic third grade. So next thing you learn in third grade, at I think the beginning of the year, is rounding. Rounding in Eureka Math is pretty regular, just what teachers would tell you to do if you're having a hard time with rounding something. It's called a number line. You may use it for fractions and decimals, but it's just a straight line with two arrows at the beginning and end of it. You have a half point. So let's say you round 50 to the nearest 100. 50 to the nearest 100. To the n100. So, if you think about this, 50 to the nearest 100. If you've ever heard the saying, 5 or more, raise the score, 4 or less, let it rest, this is the literal saying put to use. So the minimum you'll ever get is 0 in this problem, because if it was 40 rounded to the nearest 100, it would basically be 0. And the 100 is the maximum you can get when you round 50 or any number that's 2-digit to the nearest 100. And you find the midpoint of 0 and 100. You can do that by averaging it, which is adding both numbers, 0 plus 100, and then just divide it by 2. 100 divided by 2 equals 50. So you put 50 in the middle. So then you determine where your first number is, 50. So you put a dot where it is. So 50 is right on the half point. 5 or more, raise the score, so you raise it to 100. You get an answer of 100. It's just a good way of showing your work of rounding up. This is not that annoying. So you get the annual answer of 100. So let's say 40. Let's divide up the number line a little bit. So let's make that 10. Let's make that 20. Let's make that 30, 40, and you get the idea. 60, 70, 80, 90, 100. So let's say we want 40 to the nearest 100. So you locate 40, you put it on a dot, 4 or less, let it rest, so it goes to 0. That is pretty simple. 3rd to 4th grade math. You can apply the same principle when you're doing 5th grade rounding, which is rounding of decimals. Let me show you. So let's erase this. Okay, so any people below 5th grade or anyone listening, just keep on watching. So let's say about 15 and a half to the nearest 1. Okay, 15 and a half to the nearest 1. Number liney thingy. And the least you would ever get is 15. The most you'd ever get is 16. So the halfway point of that, you don't have to use the trick that I told you. You just do this. It equals, you just have 15.5 because 0.5 would be the half of numbers that are just one number apart. So 15.5. You could line it up, 15.1, 15.2, 15.3, 15.4, so forth, 6, 7, 8, 9. And you'd locate 15.5, which I think is right here, and 5 or more, raise the score, do a little arrowy thingy to 16, and bam, you get 16. You can do it to more than the nearest 1. So let's say 15.587 to nearest, let's see, 100th. to the nearest hundredth. Same thing, blah, 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 except it gets a little bit more complicated. So you'd still keep the 15, you'd keep the 10th, which is the 5, right after the point. This is the 10th, and 8 is the 100. The minimum you can get is 15.58, and the maximum you could get is 15.59. So you put that there. The half is 15.585. The 5 is a thousandth because this is one number apart, so you add another 5 there. So 5 thousandths is that. So then you determine where you are on the number line. Since your thousand is two digits above the midpoint, it would go up to 15.59. Congratulations, you are 15.59. Okay, so let's use now multiplication's inverse operation. That is a word teachers love. Use it if you ever have to explain anything. I use the inverse operation to blah, blah, blah. That inverse operation is a great word to describe the opposite. Inverse means opposite. So opposite of multiplication is division, and et cetera, division is the inverse operation of multiplication. And same thing with addition and subtraction. So, on a place value chart, it's a little tricky without knowing the answer to put 1,000 divided by 10 on a place value chart. So you have one dot under the thousands place, and then you divide it by 10. I think you draw it back. You draw it back 1 and bring it to 1, because one jump over here is divided by 10. One jump between the lines of a place value chart is divided by 10. Always remember that, because that is important when you get to 5th grade and you're doing times 10 to the 3rd, 2nd, and 4th power, and also 5th. And I'll explain exponents too, because that is important in this video. I'm ranging from 4th to 5th grade, even some 3rd grade knowledge, so anyone who wants to hear this, stay tuned. So 1,000 divided by 10 brings you to 100. And let's see if 100 right. Let's bring out my red. That will be my grading thing. So 10, I think, is 100. Let's check that. 1,000, let's do it in a long division. This is standard algorithm. I hate why they say that. 10 goes into 10 one time. 1 times 10 equals 10. You get 0, 0, 0, 0, 0, 0, 0. Wait, no, not that. Last 0. Yes, we are correct. 1,000 divided by 10 equals 100. And we got it using a place value chart. Now, what about that? It gets really annoying when you get to higher numbers and more advanced division problems. Like, for example, 592 divided by 2. That's just an example. I don't think I've done ones as long as that and as annoying as that. You can get really annoying, trust me. And so let's try that on a place value chart. So let's erase here. I'll use this. I'll just reuse the area model. The place value chart. And ba-bam, ba-bam. Erase that. Okay, so let me think of how to do this. 500. 5 dots under 100 because it is 5 and 5's under the hundredths place. 9 dots under 10 because 9's in the tenths place. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2 dots in the ones place. remember how you do it. So you add an extra liney line below this, 2 lines because it's divided by 2. Okay, let me make that a better line. Okay, then you just sum up each dot. Bam, 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 bam. 4, 5, 6, 7, 8. And the extra one that can't go in there goes to the lower one. That becomes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that goes under there too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 5. 1, 2, 3, 4. And then you move that back to there. You add another 10, and then you add that up. I'm sorry, but I don't have enough space to do the sand. I did it in reverse. You always start with the largest number. Start with the largest number, not like me, which did the first number. I'm showing you what not to do on this. The rest of the things, do what I did. This one, do exactly opposite, or inverse. Inverse, very important word in math.